In the end of chapter 6, we will use an application to show the ABCD matrix. And here, the application is the Fabry-Perot resonator formed by two curved mirrors. Suppose that we have two curved mirrors with the radius is r1 and r2 respectively. And the distance between these two curved mirrors is d. And due to that, the surface here is curved, so the phase function shall satisfy this condition. As a result, inside the curved mirror, inside the cavity formed by the two curved mirrors, there should be Gaussian beam. And of course, the Gaussian beam will have a waist in the center. Consider the Fabry-Perot resonators formed by these two curved mirrors. You can see that the Gaussian beam first hit the R1 mirror and go backward, propagate a distance of d, then hit R2 mirrors and go backward again, and propagate another distance of d to the mirror 1, and repeat the process again and again to form a resonator. So, the whole process can be considered as follows. First, the mirror 1 with radius r1 can be considered as a scene length, with the focal distance f1 is half r1. So we can start with a q value, and then it will propagate a distance of d and hit mirror 2, which can be considered as another scene length with the focal distance f2, and f2 is r2 over 2. After hit r2, the Gaussian beam will go backward with another distance d. Then hit mirror 1 again. And the whole process can be considered as first step, second step, third step, and the fourth step. And these 4 steps will form a loop, right? So every time it will repeat the loop again and again. So the whole system can be considered as these 4 subsystems. And here the Q will become Q prime. Due to this is a resonator, the Q prime should be the same as Q, because the mole will be the same. Okay? After a pass, the mole will be the same. It is the property of the resonator. Now, let's consider these 4 subsystems. For system 1, the ABCD due to F1 is R1 over 2. The ABCD matrix can be written as this way. And for system 2, clearly, after propagating a distance d in free space, the ABCD matrix is written like this. For subsystem 3, another propagation through a thin length f2. So the corresponding ABCD matrix is written in this way. Finally, another propagation of distance d with the ABCD matrix written like this. Okay, so let me say it again. The Fabry-Perot resonator formed by two curved mirrors can be considered like this. Each curved mirror just functions as a thin length with the corresponding focal distance f1 and f2 respectively. And for a round trip, it's just like passing through a four subsystems. The first one is the thin length of f1 is half r1, and the second is the distance of d. The third is the thin length of f2, and the fourth is the distance of d again. And initially, the q value of the Gaussian beam is q, and after passing through the four steps, the q is transformed to be q prime. Due to this will form a resonator. This means that the mole after a round trip will still be the same mole. So the q prime will be q. This is the condition for a resonator. And our purpose is to find out the total ABCD matrix of this cascaded system. Okay, since we have known all the ABCD matrix of subsystems, we can easily to find out the ABCD matrix of the whole system. According to what I have told you, the total ABCD matrix of the whole system can be obtained by, from the left-hand side to the right-hand side, you can place the ABCD matrix from the output to the input. According to the steps in the previous slide, this is the matrix of step 4, step 3, step 2, and step 1. So from the left-hand side to the right-hand side, we put the ABCD matrix from the output to the input, okay? And suppose that you should easily to find out the multiplication of these 4 ABCD matrices. It can be written like this. And of course, it can be re-expressed in terms of the focal distance of each curved mirror. Okay, and from these two matrices, you can obtain each element in the total ABCD matrix. As I have said, the Q prime can then be expressed as A times Q plus B divided by C times Q plus D. And according to the condition of the resonator, the Q prime should be the same as Q after one trip. And by this relationship, you can easily express that C times Q squared plus D minus A times Q minus B will be 0. And you should be very it will be very easy for you to find out the value of Q according to this equation. And the Q can then be obtained by this way. Okay. Again, this system, the Gaussian beam still goes from free space to free space, from the input to output. So the determination of the ABCD matrix also equal to the determination of the ABCD matrix is 1. So we use this equation relationship that AD minus BC is 1. Take this relationship into here. The Q value can be rearranged as this way. Of course, Q here is also defined as Z plus JB. So this term is the real part of Q, and this term corresponds to the imaginary part of Q. And we have said that the B value must be a real number. Since the B value must be a real number, which means that inside the square root, it must be a negative value. Okay? Inside the square root here must be a negative value. Then we will have an imaginary part. As a result, we can say that inside the square root, it must be negative. And by this condition, we can then have that A plus D, the total square of the A plus D divided by 4 will be smaller than 1. Then we can obtain the condition for the Fabry-Pérot resonator formed by two curved mirrors. That is so these two are the conditions for us to construct a Fabry-Pérot resonator by using two curved mirrors. What I'm saying is that if you want to form a Fabry-Pérot resonator by using two curved mirrors, you will have mirror 1 with R1, mirror 2 with R2, and the distance between these two mirrors is D. But These values has the condition which should be satisfied. If these three values they satisfy this condition, then you can successfully form a Fabry-Pérot resonator. But if these three values does not satisfy this condition, then you cannot successfully form a Fabry-Pérot resonator. This means that if you want to successfully form a Fabry-Pérot resonator like this, these three parameters should satisfy this condition. Okay? So this is an example of the application of ABCD matrix.